All right. So previously we built the Excel sheet that had a bunch of columns here. I don't have that sheet anymore. My computer shut down and it didn't save anything. Hopefully you still have that. But we had a bunch of data here. Okay. That was doing the calculations that we see right here. Okay, these sums of x times y, the sum of x times the sum of y, the sum of x squared, the sum of x squared, same thing for the y's then, and we programmed it to where it would capture just these data values, and once it captured those data values, it just spit back automatically the correlation coefficient, okay? And we built that, okay? Now, what I want you to understand is that every time that we type something, so when I hit equals here, and basically when I hit equals, I have access to, let's see if we can get all of these to show up, okay? I have access to all of these different functions that occur as I scroll through here for Excel, correct? Okay. Now, each one of those is built with a program in the background just like we built. Does that make sense? Okay. So if we type in equals and then CORREL, okay, so that's the command that is going to reference essentially a program exactly like what we built. Okay, the user interface is a little bit nicer here than what we built, but it does the exact same thing. You're going to tell it what do we want our x's to be. Okay, so we're going to highlight those as our x's. Okay, then we're going to hit a comma, and you see the components or the conditions is usually what we call them for this command. It says array 1 and array 2. An array is just a list of values, okay, but that wants them as in the order of independent variable, comma, dependent variable. So now I'm going to highlight. So now I hit comma. I'm now in array 2. So I'm going to highlight that. Okay. So that's exactly what our program did when we started typing in our x values in column A and our y values in column B. Okay. Close my parenthesis. And we now have our correlation coefficient. Okay. Which was the exact same thing. So and it does it instantaneously, but it does the exact same stuff that we programmed to do. Does that make sense, everybody? And I think, because some people, Chuck in particular, they said, "Faye, we had 40 minutes on that thing just to get one question." And it sounded just like that. But really, it did take 40 minutes to get that one question, to address one correlation coefficient. But now it's a dynamic program that is going to instantaneously find you solutions to every other question once you put your data in, right? Does that make sense? Now, you're saying, well, why do we do that? Because this already has a built-in feature. Correct, okay? But the practice of using Excel like that can help demonstrate how I would address something that Excel does not have a already built command for. Does that make sense? Okay. And I like to build, especially early on when we're learning Excel on our own, build little programs that match to commands that Excel already has, because then I can check to see if my built program works. Does that make sense? Okay. If we were to use our program that we built the other day and use this data, you're going to find out that they give us back the same correlation coefficient, so we know we built it right. And I think that's a byproduct of statistics. Okay. At some point, you guys, are you going to use Excel to do hypothesis testing outside of this class? I don't know. It depends on what you go into. Will you have to, watch a commercial or watch a advertisement or some type of newscast or something like that asks you to interpret statistics as an intelligent individual? Yes. But will you go to the degree of hypothesis testing and stuff like that? Probably not. But will you all have mortgages, credit card debts, college debt, hopefully an income that is greater than all of those things monthly combined? Okay, garbage debt, cell phone, TV, what else? Maybe child support. But you're gonna have money coming in, money coming out, right? You might want to build a budget using Excel that you can type those things in, and it tells you monthly, hey, this is what you have available. And to do that, I think using some of the stuff that we've learned here, doing this kind of stuff with commands, some formulas, that kind of stuff, can maybe help do that. Speeding tickets. Shut up. You have to find somebody to marry you before you have alimony. Yeah. Bail? Restitution? Okay, so this number is pretty close to -1, correct? So what would we argue that this, I don't even know what the scenario of this data that I get, it says maximum weight and time, but as the weight goes up, okay, what are we seeing that the time is doing? And I guess, so let me rephrase that, because look at my data values. Are my data values, are they sorted? Are they in order? No. So what we can do, we can actually do this. I'm going to click on that column. I'm going to go to data and see where it says sort. Okay, so I'm going to click on that. So it's going to sort, so it wants everything that I'm going to sort, so I'm going to click yes. So it's going to ask for me to select all of my data, and actually, let's just select these two. So we'll sort, and now we can sort it doesn't really matter, we can sort the maximum weight based on cell values, and that's what I'm going to do. I'm just click on the first one, click on cell values, let's go smallest to largest, we'll hit OK, and you can see that it now sorted them. And now as the weight is going up, right, that's what these are all doing, what is happening to the time? Time is going down, okay? And it's linearly going down. If we were to graph this using, so I'm going to select those, I'm going to click on the scatter plot chart, okay? And you can see then that is what is happening there. It's not a perfect linear correlation, okay? But it is linear, and we're seeing that with that -0.9, was it 6 or something like that for our correlation coefficient, 0.946, okay? Does that make sense? Okay. Let's see here. All right, so a t-test can be used to test whether the correlation between two variables is significant. Okay, so the test statistic is R, okay, which is our correlation coefficient, okay, and the standardized test statistic then is found by taking this. It's going to be R divided by the standard deviation, okay, which that standard deviation sub R is found using this tool here. Okay, the standard error is found by taking the square root of 1 minus your correlation coefficient squared divided by n minus 2, where n minus 2 is your degrees of freedom. Okay, so it's still a traditional hypothesis test using the t-distribution, but now the hypotheses are going to be The variable that we're going to use is rho, okay, which is spelled RHO, but it's this italicized looking P. Okay, it's not italicized or anything. It's a Greek letter. That's how you write it. And the alternative hypothesis is going to then be the complement. Okay, so what we're looking for here. So the idea with a and then this is why the hypotheses tests are, or the hypotheses are always built this way. They're going to be rho equals 0 as the null hypothesis, and rho not equal to 0 as the alternative hypothesis. Okay, because basically what we do is says the null hypothesis always, it's always that we make the assumption that there is no correlation. If I make the assumption that there is no correlation, then I let the data play the role of determining whether there is a significant correlation or not. So if I reject the fact that there is no correlation, that tells me that there is a significant correlation. Does that make sense? Okay. Or if I fail to reject that there's no correlation, then there's no correlation. Okay. So that's why we set the hypotheses the way that we are going to with rho equaling 0 as your null, rho not equal to 0 as your alternative. So to specify the level of significance, okay, that's obviously going to be provided for us. Degree of freedom will be in -2. We can determine the critical values using Excel, GeoGebra, Desmos, whatever you want to use, TI-8384. We'll find the test statistic. We'll make the decision on the null hypothesis, and we'll interpret the results. Okay. If we want to use p-value techniques, we can do that as well. Yes, Blaze. Say again. To find critical values, it's going to be the norm.inv or t.inv, depending on what distribution you're using. So it's the INV one. For us right now, it's going to be a t.inv. And if you forget that as you're maybe working on a test or a quiz, try the t.dist and see what kind of number you get back, and try the t.inv and see what number you can get back. If you get back a probability, okay, then that's not what you want. You want a critical value. And if you type them in, remember when I type them in before I start hitting in or typing in my conditions. So when I hit like t.inv, open a parenthesis, it will show me the stuff that I need to type in. Okay, if it says X first, X is essentially a critical value that I need to type in. So I don't have that. I'm looking for that. So I use the other command that I didn't use. Does that make sense? So I'll show you that real quick here. I wish I could zoom in. Maybe I can a little bit here. All right, so if I hit equals t.inv, open parentheses, see how it says probability, comma, degree freedom? So that's what I'm going to use to type in. So when it says probability, degrees of freedom, that means it's going to give back an X, because that's what's missing, right? If I type in t.dist, you see how it says X first right there? That X is referring to a critical value. So they're saying, do you know your critical value? Or essentially our test statistic is what we would normally put in there. But we don't know that. So if I want to find the critical value, I don't use this. I use this. Because in finding the critical value, remember, is based off of alpha, right? And alpha is a probability. Is that cool? Let me zoom back out. All right, so let's just run through an example here of this. Try to keep the size of our data somewhat small, because we're going to use Excel to do this. I don't want you guys finding all these correlation coefficients by hand. On the flip side of that, also, if we're not going to find it by hand, which is nice, we still at least have to type that in. Does that make sense in Excel? If you go to Schoology and you download my notes, they download as a Word document. If you highlight that Word document, then that table in the Word document, you can Control-C that and then go to Excel and Control-V it, cut and paste it. That might be quicker than just typing them in. And that's actually what I'm going to do. So if we were to show you that process here. So open the Word document, scroll down, and you see an example that we're going to do probably tomorrow. There's a lot more data that you don't want to type in. So I'm just going to Control-C or right-click, copy, and then I'll go into Excel. And I'm going to hit Control-V, paste everything in for me. You can format that as you see fit. But that's our data. Okay? So, what the question is asking, it says, an economist wants to determine whether there is a linear relationship between a country's gross domestic product and carbon dioxide emissions. So the data are shown in the table, display the data in a scatter plot, and then determine if the correlation is significant. Okay. So basically what we're saying is they want to determine if we manufacture more things. That's basically what your gross domestic product is saying. Does that make sense? Okay. That you are a greater manufacturer. Does that then yield a greater amount of carbon dioxide? Okay. So hopefully, maybe from our science background, maybe we have the idea that could be a direct link between those two. Okay. But now we're going to actually run through the test to see if indeed it is. So the first thing we're going to do is we're going to set up our hypotheses. So we're going to say, come on, H sub 0. Okay. We're going to say rho is equal to 0. And what that means to us, okay, that means that we're going to make the assumption that there is no correlation. The alternative is that rho equals 0. Okay? Just be careful with how you, because a lot of times, rho looks like P, so you might be thinking proportion instead of correlation. Just be careful with that. So the data are shown on the table, display the data in a scatter plot, then determine if the correlation is significant. So our scatter plot would look something like the following. So I'm going to take this data here, okay, and select those. And now if I go to Insert, Scatter Plots, okay, you can see that it looks like there's probably a linear correlation here, right? That's what but that's subjective. If I just say, yes, there's a linear correlation, I don't know the degree of it. I don't know if that's actually 100% true. Okay, I could be wrong. Does that make sense? So we want the data to produce this for us. Okay. Is that okay? Okay. So that's find the scatter plot. Now let's actually do the test. Okay. So the test statistic, okay, is rho. So T is going to be our correlation coefficient divided by the square root. Okay, it's 1 minus r squared over n minus 2. 1 minus r squared all over n minus 2. Okay, so that's the test statistic. I find the test statistic by taking this data and finding the correlation coefficient. Okay, well, that data is already in here. Okay, so I'm going to type in one of these cells equals CORREL. When I highlight that column, hit comma, highlight that column, close it off. My correlation coefficient is 0.88. Okay, 0.88, I'm just going to round it, 0.8825. So this would be 0.8825 all over. Now it'll be 1 minus 0.8825 squared over n minus 2. Okay. Now I think I've got 10 data values here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n minus 2 would be 8. Okay, so all that's underneath that square root. So we calculate that. Looking at 0.8825 divided by square root 1 minus 0.8825 squared over 8. All right, so we're getting our test statistic to be 5.307. T equals 5.307. Okay? Okay. Now we have to take and figure out, okay, well, what do I compare that to? Okay? Alpha was 5%. Okay? So what we're going to do, remember it's the T distribution, so we need to take our T curve, okay, our T distribution curve, and we're going to, because it's a two-tailed test, we're going to have 0.025 in that area and 0.025 in that area, right? Now we need to find what those critical values are so we can compare it to 5.307. Okay, so we are going to go to Excel. I'm going to hit equals. Okay, now we go T.inv. Okay, and you can see that it says probability because I want the critical value being the output. So the probability is that alpha or the alpha of 2, depending on what kind of tailed test we have. We have two tailed tests. So instead of alpha, it's actually going to be alpha over 2. So that's why 0.025. Degrees of freedom. Now, in this test, the degrees of freedom are 8, right? That was n minus 2. And I get negative 2.306. Negative 2.306. So that's what this number here is. This number here would be positive 2.306. Okay? Where's my test statistic at? It's out here, right? Okay, and it's probably even a lot further to the right than that, but it's in the rejection region, correct? Okay, so we are going to reject this. Reject H sub naught. Okay, which, remember what that said. If I reject a null hypothesis that establishes that there is no correlation. I'm rejecting that there is no correlation. So what am I saying? There is a correlation. Okay? We are saying here that there is at the 5% confidence level, or sorry, the 5% level of significance or correlation significance level, that there is a correlation between the two independent and dependent variables. Does that make sense? Okay. Now, what I want to talk about real quick here, does that mean that the GDP, the gross domestic product, is the cause of more emissions? It does not. Okay? It does not mean that it's the cause. It does mean that there's a relationship, that they're related somehow. Okay? I'm going to scroll down here. Okay? It says it is important that we understand that correlation does not imply that there is a cause and effect relationship between the variables. Okay? So correlation does not imply causation. Does that make sense? Okay? It says that the correlation is significant. A researcher will want to dig deeper into the variables and try to determine if there's a direct cause and effect. If, does GDP actually make CO2 emissions greater? Okay. Or to see if there's reverse cause and effect. Okay. Does greater CO2 emissions create a greater GDP? Okay. Most likely, probably not. Okay. Or perhaps a third variable or several other variables are present, and those relationships maybe need to be analyzed. Okay. But the correlation between two variables can be complete coincidence. Does that make sense? Okay. We might be able to take like the number of days that you've been alive and the number of days that's been sunny out for each student in here. And we might see that there is a correlation. Does that mean, based on how many days you were alive, that causes the sun to be out? Well, that's kind of ridiculous, right? Okay, but there can be a strong correlation between, or strong relationship between, but it does not mean that one causes the other. Okay, so that's something to be very important, or very aware of, and is very important as we investigate correlations. Is that okay? There's a command in Desmos that gets you correlation as well. But I think we might run out of time typing that stuff in right now, so we'll do that maybe tomorrow. There is, so that assignment 10.1, I'm going to, it was due today, I think, right? Today at midnight. Let's just, I'm going to leave that at midnight tonight. Just make sure you finish that up. It's only 12 questions, I think, or 14.